So we have been building these relationships based on different things. So we looked, for instance, for this mentoring relationship, which said one student can help another student if there is a big separation, but not too big a separation. Then we also said
one
subject, and then we also looked at the other way around, saying that students are similar if they are very close in all subjects and so on. So then we drew these things as graphs, sometimes directed, sometimes undirected, and then we said we were looking for patterns in these graphs.
Right.
So by looking at the graph structure, we can understand something about the relationships between the cards.
Looks like that, yeah.
So one thing I was wondering is that supposing you look at somebody like this card number 24, right? So it looks like this card number 24, for instance, at least from whatever cards we have already looked at in this earlier calculation, that this person can be mentored by 2 people in maths and can mentor some 4 people in physics.
Oh,
so
really?
So this card number 24 has 2 maths edges coming in.
Let's see.
Right, so you can see that there are 2 maths edges coming in, and if you can find the physics things.
I see.
Right, so we can find these kind of interesting students, students who are kind of somewhere in the middle, who can be mentored by a lot of people and who can also
very likely that these students are likely to be the more liked students in the class.
Yeah, because many people can sort of relate to them somehow.
Yeah, because they are neither too good nor too bad.
Yeah, so everybody has some feeling that either they can help them or they can be helped.
They can be helped or they help, so something.
Yeah.
24.
So basically you can see that people who do well in maths can help him, whereas he has reasonable physics marks, so he is able to help people who do poorly in physics. So he can form a lot of friendships or connections this way. So this could be one thing that we can identify. If
what do you call him? What do you call people like this?
Well,
popular?
I guess, popular, why not? Popular. So many people might be interested in knowing this person, because they have some connection in some sense.
So I would suspect, given that the marks are running from 40 to 90 type of things, 80.
Yeah.
70.
Yeah, so somebody is in the middle.
The middle, right? 70.
Will have some.
It's like this guy, 72.
Yeah.
So 70, if you have 70 in all subjects, basically, let's say.
Yeah, so there will be people who have in the 80s who will be able to mentor.
80s who will be able to mentor him. Many people in the 60s, he can mentor.
Correct.
So you should have many.
Correct.
What do you call this? What do you call this? 24 has things coming in.
Yes. So
name for that?
Yeah. So we have this incoming. How many incoming edges are there?
Incoming edges.
Yeah. So sometimes that's called the degree. The degree of.
In degree.
Yeah. So the degree of a node is how many edges are there around it.
Okay.
But because we have directions, there is an incoming degree and an outgoing degree.
Out degree.
So
in degree and out degree. So we are looking for nodes which have a large degree.
Combination of in and out.
And ideally good in degree and good out degree.
Yeah. So for instance, we can see that somebody like this number 11 who had very high marks in maths will have a very high out degree because they can mentor people who are below. But because this is the highest mark in maths, they will have no incoming edges. So the in degree will be 0.
So not very popular.
Not
very popular.
It's more likely to be popular if you are in the middle range.
Middle range.
If people are above and
well,
below.
let's find somebody who's got.
Yeah. So let's take some
70 type marks.
Yeah. So this is let's see. This is one possibility.
JK, the 60s, all 370s, something like that we should see. We may not find anybody like that.
Yeah.
I don't know.
Close to 70 at least if we find.
No, this is 51. 52, 64, 71. This is 80. It's a little high. This is also high. This is okay, no?
This is okay.
Kavya. 64, 72, 68.
Yeah. So likely to be.
Right. This first one also seemed okay. We'll keep JK also. This is 52. This is 56.
80s.
74, 83.
High on the higher side.
Bit on the higher side. 71, 92, 84. 72, 92, 97. Okay.
So these are our 2 candidates, right? So we are trying to see whether.
Also we can keep.
These three have got high degree. So let's try and compute their neighbors
Okay.
in this mentorship graph.
Okay, actually.
So
Okay, I got 4.
we have 4.
Enough, I think we'll do.
Okay, so let's see among these 4 who is the most popular.
Okay, let's find out.
Right?
Yeah.
So we have
So
10.
we're saying that they should have large degree,
Yeah.
large in degree, large
And-
out degree.
Yeah. So we'll have to go through and check for each subject who are their neighbors whom they can mentor and whom they can be
Okay,
mentored by.
all right.
So right here we can check, for instance, so Kavya within this group, so 10 to 20, right? So 26 is an incoming. So I will draw it like this, these lists,
Okay.
right? So this is the maths list, right? So the maths list has 26 as an incoming thing, and it has 21, right? Because it is between 10 and 20.
Yeah.
But nobody in this group can be mentored by Kavya and maths. And then we have to go to physics, but physics they're all very similar, so they can't mentor each other. Chemistry again 26 can mentor, 82 can mentor 68. But these two are, so it's between 10 and 20. So 26 is also a chemistry neighbor of 10. So this is within this group, but we have to do it for all the
26 can mentor 10
in physics, in chemistry and
in
maths.
JK, right?
Yeah, JK can.
JK seems like a good candidate to.
Yeah, so we'll have to do a similar thing for JK also. So we will have a 26 list. So for each of these 4, what we will have to do is construct
lists.
These in and out lists for
In and
all
out degrees.
and then see which one of them has the
Highest degree.
Okay. So we can just start off by creating these spaces 26, then 0 and 21. So these are our 4 candidates, and each of them has this maths, physics and chemistry, these 3 possible lists, right? So
Each is a list.
each is going to be a list, so we will fill them in as we see cards. But we can do it all in one shot, right? So for each card we can put them in all the lists for all the 4, we can compare them, so we don't have to do it again and again.
Okay.
Right? So let me just draw it for this person also.
So we examine these, we don't need to see these cards, yeah?
Well, we will have to, because each of them will have to compare with this.
But this, all 4 with each other you have done?
With each other, I think there are no, 21 can no, we have done only for 10, right? Because we have to write down the list explicitly for everybody.
Let's do it systematically then.
So we did it for 10.
Okay.
Now let's do it for 26. So 26 can mentor 10 in maths, that we already said. 26 can mentor 10 in chemistry. Right? And 26 cannot mentor anybody else in anything.
And who can mentor 26?
Who can mentor 26? Nobody, I think, is got more than 10 marks. Now if you go to 0, then I think we're done. I think 0 is 21 can mentor
0
in maths. So therefore
0 can
21.
be mentored by 21.
Yeah.
You can enter in both places, yeah. That's
and
about it,
that's
right?
about it, yeah.
Okay, so now we only have to look at,
Yeah.
we are not keeping this node, we are not looking at this as a node, right?
Yeah, we're just going to put it in one of these lists. So
Okay, so
72, so maths it doesn't go with anybody.
72, 66 again, no, 68, 81, yes.
Yeah, so
29. So
29
10 can be mentored by 29
in chemistry.
in chemistry.
Okay. Okay.
Let's look at this.
Uh,
So
no.
74, 72, 71, 76,
No.
82, 81. Okay, let's look at this. Again, 29 can mentor 0.
29 can mentor 0 in? No, we can't. It's only 4 marks.
No. Okay.
Again, it's within 7 marks. Within
all of them.
yeah.
So, no. So done.
So
done this card?
Yeah, this is done. We can
Okay.
move it aside.
You got it, right?
So let's keep some space here so that we have space for okay. So that is done. Okay. Now we'll do the same thing here.
So
65,
65,
we come-
73, 69.
Yeah. So that is again. So
13, Kavya can be mentored by 13.
in chemistry. Okay.
74, 65, 71, 73, 82, 89.
No.
Okay. 68, 65, 64, 73, 78, 89.
89, yes. So
13 can mentor 0.
13 can mentor 0 in chemistry. Okay.
In chemistry. 78, 65, yes. Monica can mentor Gopi. So 21 can mentor 13
In maths.
in maths.
Okay.
69, 73, 74, 89. Here again.
So 13 can mentor 21 in chemistry. So actually they could form a study group in maths and chemistry.
Yes, yeah, actually, yeah.
Okay.
Okay, Gautami.
76,
64.
15, so she can help in maths. Okay.
72, 58. So
Physics also.
Kavya can help Gautami.
Gautami can go.
Again, they can make a study pair.
Okay. And chemistry.
90 chemistry again. This is looking good. Huh?
Okay. Okay.
Then JK Gautami. 76, 74, 71, 58.
So 26 can help
mentor.
15. Okay.
82, 90.
No.
Okay. 68, 76.
No.
64, 58. Yes.
No. Okay, yeah, sorry. No, it's
No.
only 6 marks, yeah. But
78,
this 7,
yes.
yeah. So 15 can mentor 0 in
Chemistry.
chemistry. Okay.
Okay. 78, 76, 69, 58.
Yeah, so Monica can mentor in physics. Right. Okay.
90, 74.
Okay. So it certainly looks like number 10, Kavya has got more neighbors than anybody so far at least. Okay.
Okay. 64, 62, 72, 45.
Yeah, so 1 can be mentored in physics. Okay. And chemistry.
91, 68.
Okay.
Okay. 74, 62, 71, 45.
So 1 can be mentored in maths and in physics. And chemistry, there is no mentoring. It's only 9 marks.
Here also you can't. 74, 62 is
12 marks.
12 marks. Okay.
Yeah.
Sorry. Yeah. 68, 62, 64, 45.
Yeah, so 0 can mentor 1 in physics.
91, 78.
Okay.
Yeah.
1 can mentor 0 in chemistry.
Physics.
Maths, the other way.
Maths.
So 21 can mentor 1 in maths
Physics also.
and in physics, and chemistry is the other way. Okay.
Oh, this is a good pair. All right. Rahul. We'll stop after some time.
Yeah.
Okay. 97, 64.
Yeah, so Rahul can obviously help in maths
92, 72.
and in physics.
And everything. All three.
Yeah. So
I can do for everybody, I think.
Yeah.
All three. All of them. All of them. All of them. Okay. So that's easy. Rita.
Okay. So maths, she is on the right side, 3. Physics also, she is low, so 3. Chemistry is 10 marks. So chemistry we said 10 inclusive,
Yeah.
right? So 3 comes here.
GK.
JK can help in maths and in physics,
But not chemistry.
not in chemistry. Bhuvanesh can help in maths and in physics,
And not in
not in
chemistry.
chemistry. And Monica can help in maths and in physics,
But
and not in chemistry.
Okay. So we stop and we'll see what we get.
Okay, so we can stop and see what we get.
Hmm.
So now we have to decide what the criterion is, because we have some cases like 3 is a physics target and a maths. I mean, this 10 can help in both. So if you're talking popularity, it doesn't matter which. So we have to collapse, I think, these duplicates. So we have to look at on the right hand side. I would say that 10 can help
1, 3 and
1,
15.
3 and 15.
3 people.
Right, so it is 3 people. So 1, 3 and 15. So it's 3 people. And on the inside input side we have 11, 1, 3. So now again see 15 comes on both sides because sum is this way.
Correct answer. Yeah.
So we'll see what to do. 15, 13, a lot of them. 21, 29,
You can remove the duplicate. Right?
26. Right, so now we will remove the duplicates from both sides. So we can say the 3 can be removed from here, 15 can be removed from here, 1 can be removed. Yeah. So 10 has 5 plus 3, 8 neighbors.
8
5.
neighbors.
Yeah. If we count only the distinct one. Right? So 10 has 8 neighbors.
So 5 it can help, and 5 basically something like that.
Yeah, something
So
like
8.
that.
So 8 people, 8 people 10 can interact with,
Yeah.
right?
Yeah.
There is a reason to what out of the cards you've seen.
Out the cards you see. Look at 26 on the other hand. On the right hand side we have 1, 3, 10 and 15, and on the inside we have 11. So there are only 5 people that 26 can interact with, right? And this is 1, 3 on the outside, and 11, 1, 15, 13, 21. So this is 7.
Okay.
And this is 0, 1, 3, 13, 15 on this side. And on this side it is 1 is already there, so I will leave it out. 13 is already there, so I will leave it out.
11.
So it's 11 and 90. So this is again 7.
90?
90, oh not, it can't be 90. So what was that? I think 90 was the marks. I think I mixed up something.
Okay.
So I don't know who it was. 15. Look at the chemistry marks of 15.
Yeah, it's 15.
So this is 15. So that is already there. So this is actually only 6. Right? So what we have seen is by looking at,
so far it looks like Kavya is the most popular.
yeah. So if we look at these 4 people and compare them amongst themselves and another, however many, 5 or 6 sample things, Kavya has a popularity of 8, and the next highest popularity 7 is of 0, which is Bhuvanesh. Then Monica has 6, and you can also see in some sense that JK is on the higher end of the spectrum. Has is more so has fewer things. So the ones who are more middleish. So again here the 78, 74, these are 2 higher scores. So it looks like 60s is where the really popular people are. As you go to the 70s, you have you're already an overachiever in this class, I think. So we could do this now, and we could. So
again here, what have we done? We have taken tried to create a graph, right?
Yes.
We're trying to take nodes and connect the nodes to each other.
Yes. So we're doing the same graph, that we did before, but we are just doing a different analysis with that. We are just trying to see for each node what is the concentration of edges around that
You're
node.
counting the in degree and out degree of that.
And then we are doing a little bit more, because we are saying that if the like this 24 has an in 2 and an out 2, we would say that it has only one neighbor. So we are not counting the neighbors. So we are counting how many distinct
neighbors it has
across all the incoming and outgoing. And based on that, we are assigning this notion of popularity, and we are trying to identify who's the most popular. But in some sense, if we had first constructed this graph properly, right? Once we have constructed this graph, we don't have to go back.
You don't have to go back to cards.
So this problem,
a lot of things like this, popularity, mentoring.
So all the details of those marks, everything is hidden inside this graph. We don't need to know anymore what are the exact marks and do this recalculation every time. So this graph is a nice way of capturing this
essence of the relationship, right?
Relationship once and for all, and then we can do many different kind of things with that. So that's a very useful data structure to capture this summary of this information.